Ever wonder why Rh-negative blood is so rare? Right now, as you sit and feel your own pulse, there is roughly a 1 in 7 chance that something unusual is moving through your veins. On the surface of nearly every human's red blood cells sits a tiny protein called the Rh factor, but millions of people are born completely without it. And that single missing piece, marked by nothing more than a minus sign on a blood test, has puzzled scientists for almost a century. Some say it points to ancient bloodlines. Others whisper about hidden origins, lost civilizations, even visitors from the stars. The stories are everywhere. But today, we are going to do something different. We are going to walk straight past the myths and look at what your DNA actually says. Why does this trait make childbirth dangerous, yet refuse to disappear? Why does it almost vanish across entire continents, then suddenly spike among one mountain people in Western Europe? And what does that pattern reveal about where your family truly came from? This isn't a legend, it's a survival story written in your blood, and the real answer is stranger than the myth. On a quiet day in 1940, in a New York laboratory, the immunologist Carl Landsteiner was chasing a question almost no one else thought to ask. He had already won a Nobel Prize for discovering the major blood groups, the breakthrough that explained why some transfusions saved lives while others killed within minutes. But Landsteiner sensed the story of human blood was not finished. Working with his colleague Alexander Wiener, he took blood from rhesus monkeys and injected it into rabbits, prompting their immune systems to build antibodies. Then, he tested those antibodies against human blood. In most samples, the red cells clumped together, a sign the antibody had recognized a familiar protein on the surface. But in about 15% of samples, nothing happened. No clumping, no reaction. The protein simply wasn't there. It wasn't a disease. It wasn't damage. It was absent. They named this element the Rh factor after the rhesus monkeys that revealed it. The protein itself, the most important of the group, is called the D antigen. If your red cells carry it, you are Rh positive. If they lack it entirely, you are Rh negative. To your immune system, the D protein works like an identification card, a marker that says, "This belongs here." When the body is used to seeing it, all is calm. But introduce that protein to someone who has never carried it, and the immune system may treat it as an intruder and attack. On a medical chart, the difference is just a small plus or minus after your blood type. Yet behind that symbol lies an entire story of immunity, of pregnancy, of transfusion, and of the deep migration history of our species. And it all begins with this strange, quiet fact that 1 in 7 of us is built without a protein the rest of humanity carries without ever knowing it's there. In most pregnancies, the bodies of a mother and her unborn child work together in a way that feels almost miraculous. Their blood never mixes directly. Through the placenta, oxygen and nourishment pass quietly across, sustaining a new life. But when the mother is Rh negative and the child inherits the Rh positive factor from the father, that gentle arrangement can turn into something far more dangerous. During a first pregnancy, things usually go well. The mother's immune system has never met the D protein, so it sees no threat, and the placenta keeps the two blood supplies almost completely apart. The critical moment often comes at birth. As the placenta detaches, a small amount of the baby's blood can slip into the mother's circulation. For the first time, her Rh negative body sees the D protein, recognizes it as foreign, and begins building antibodies against it. She feels nothing. There is no pain, no warning. The first child is usually born healthy, but her body now remembers. If a later pregnancy carries another Rh positive child, those antibodies can cross the placenta and attack the baby's red blood cells. The fetus grows anemic. Its heart strains, its organs swell, and in the worst cases, it cannot survive. For most of human history, mothers had no idea why this happened. A healthy first child, then a second lost within hours, then a third. Parish records across Europe still hold the names of babies born and gone within days. And behind those brief entries lies grief no one could explain. No one was at fault. The mother did nothing wrong. The child carried no flaw. There was only a tiny difference between two bodies. Then, in 1968, came the turning point. Researchers developed an anti-D injection, known today as ROGAM. Given at the right moment, it clears the baby's Rh-positive cells from the mother's blood before her immune system can remember them. No antibodies form, no silent war begins. A tragedy that once spanned generations was ended by a few quiet minutes in a doctor's office. If Rh-negative were just a random genetic quirk, you would expect it scattered evenly across the world, roughly 1 in 7 people everywhere you looked. But when scientists began to map it, the pattern made no sense at all. It doesn't spread evenly. It clusters in some places and almost vanishes in others, as if an invisible hand had drawn borders across the human genome. Look east, and the trait nearly disappears. In China, Japan, and Korea, Rh-negative blood drops to a fraction of a percent. Across most indigenous communities in sub-Saharan Africa, it is almost absent. And in the Americas before European contact, the native population was overwhelmingly Rh positive, the negative type barely registering at all. Then turn to the western edge of Europe and everything changes. Along the Atlantic coast, in Ireland, in Scotland, in parts of France and Spain, the numbers climb far above the global average. The trait that flickers out across whole continents suddenly burns bright here, hugging the coastline like a tide line left behind by something ancient. And at the very center of this western cluster sits the strangest case of all. The Basque people, living where the Pyrenees descend toward the Atlantic, carry Rh-negative blood at rates reaching 30 to 35%. In some Basque communities, roughly 1 in every 3 people lacks the D protein. That is no longer a rare trait. It becomes a defining genetic signature of an entire population. So the map forces a question. Why would a minor biological feature concentrate so heavily in one small corner of Western Europe, while most of the world records only the faintest trace? Did the mutation arise here first? Did isolated communities preserve it across thousands of years? Or did being Rh-negative once carry some hidden advantage in this particular place? The distribution looks less like random chance and more like a record, a faded map of migrations, isolation, and survival, written quietly into the blood of people walking among us today. And nowhere does that map point more sharply than at the Basques themselves. To understand why this trait concentrates in one small corner of Western Europe, we have to travel to the land where the Pyrenees descend toward the Atlantic, home to one of the continent's most puzzling peoples. For centuries, the Basques have unsettled scholars. Their language, Euskara, belongs to no known family. It isn't Spanish. It isn't French. It has no clear relative among any living language on Earth. Linguists have searched for connections and found almost nothing, as if Euskara were the lingering echo of a world that existed before the languages we know today ever arrived. That strangeness runs deeper than words. It runs in their blood. Modern genetics doesn't treat the Basques as a people entirely separate from Europe, but study after study shows they have held on to a remarkable degree of genetic continuity across thousands of years. Villages tucked into the mountains, a language that locked them apart, and tight community ties all limited intermarriage with outsiders. And in populations like that, rare traits don't get diluted away. They can hold steady, even rise, generation after generation. Rh-negative blood is the striking example. Where the global average sits near 15%, some Basque communities exceed 30%. To geneticists, this doesn't mean the Basques are mystical or fundamentally different from the rest of us. The real meaning lies elsewhere, and it's stranger for being true. In a world endlessly reshaped by wars, migrations, and the mixing of peoples, a community that preserves its continuity becomes something rare, a living archive. The Basques let us glimpse traits that were once more common across ancient Europe, traits that elsewhere were diluted and washed away by later waves of farmers and conquerors. Then came a striking confirmation. When geneticists examined remains from Europe's Ice Age hunter-gatherers, they found these ancient populations far closer to modern Basques than to most other Europeans. They were not a side branch of history. They were a window into Europe before Europe as we know it, carrying not only an ancient language, but an ancient signature still flowing in their veins. Here lies the question that has nagged scientists for decades. If being Rh-negative once raised the risk of losing a child, why didn't evolution simply erase it? By the cold logic of natural selection, a trait that costs you offspring should grow rarer with every generation, fading toward nothing. Yet, it didn't fade. In places like the Basque country, it flourished. The first part of the answer is less dramatic than the myths, and far more powerful. It begins with a small change in the Rhd gene, the stretch of DNA that builds the D protein. In Rh-negative people, that gene is missing or switched off, so the protein is never made. Mutations like this appear constantly across human DNA. What decides their fate isn't just the mutation, but the story of the population carrying it. In small isolated groups, pure chance takes the wheel. Geneticists call it genetic drift. Picture a mountain village of only a few dozen families. If one of the founders happened to be Rh negative, their descendants could carry that trait forward until it became common, not because it was better, but simply because it was there first. That's the founder effect. Add in bottlenecks, the brutal population crashes caused by famine, plague, and war, and rare traits in the survivors can suddenly dominate the generations that follow. But drift may not be the whole story. Some researchers suspect Rh negative once offered a faint advantage. Studies have explored whether it changes how the body responds to certain infections, including the parasite Toxoplasma gondii, which silently infects roughly a third of humanity. The findings are intriguing but modest, often unconfirmed in independent work. If there was ever a benefit, it was likely small, a slight shift in the odds of surviving a disease, not a superpower. And in evolution, small is enough. A few percent of extra survival, repeated across thousands of generations, can carve a permanent mark into the human genome. Before I show you the last part, if you've ever looked at your own results and wondered where Rh-negative blood fits into your bloodline, I put it all together in a guide called Where Do You Really Come From? Link is in the description. But stay right here because what comes next is the part most people completely miss. Whenever science leaves a gap, imagination rushes in to fill it, and Rh-negative blood has drawn more than its share of legends. For centuries, Europe's nobility were obsessed with what they called blue blood. A bloodline wasn't just a family matter, it was the foundation of power, the proof that certain families were born to rule. To guard that supposed purity, they married within a narrow circle. Cousins wed cousins. Princes married princesses from the same handful of dynasties. The same pool of genes was recycled again and again. It looked like a way to concentrate power. Biology tells a darker story. When a population closes itself off, rare and dangerous genetic variants get more chances to meet. The clearest example traces to Queen Victoria, a carrier of hemophilia, a disorder that stops blood from clotting properly. She showed no symptoms herself, but the gene spread through Europe's royal courts by marriage. In Russia, her descendant Tsarevich Alexei suffered terribly, and the family's desperate search for help drew the controversial figure Rasputin into the heart of the empire in its final years. The walls built to protect royal blood ended up cursing it. Then come the wilder theories. Some claim Rh-negative blood is a relic of Atlantis, its scattered hotspots the last traces of a drowned civilization. Others insist it proves alien ancestry, that someone engineered a branch of humanity long ago. These stories spread fast because they answer a deep human craving, to feel that something rare inside us connects to something vast and hidden. But the evidence points elsewhere. The trait is a natural deletion in a single gene, shaped by drift, isolation, and the slow grind of survival. And here is the irony the myths miss. The grounded truth is the stranger one. Rh-negative blood doesn't need Atlantis or visitors from the stars to be remarkable. It is a record of real human resilience, a costly trait that should have vanished yet endured, written quietly into ordinary people walking among us today. For all its ancient mystery, Rh-negative blood is also a very modern matter, and in an emergency, it becomes one of medicine's most precious resources. Picture an emergency room at 3 in the morning. A patient arrives after a serious accident, losing blood fast. There's no time to wait for full lab results. In those few desperate minutes, doctors need a blood type they can give to almost anyone. That is O negative. Because it carries no A or B antigens and lacks the Rhd factor, O negative can be transfused safely in most emergencies, the universal lifeline when every second counts. That makes O negative donors extraordinarily valuable, because the type is rare. In many regions, only a small fraction of people carry it, yet the demand is constant, for accident victims, for surgeries, for newborns needing emergency transfusions. Blood banks know it well. O negative is one of the first types to run short, and supplies can fall to crisis levels within days. Pregnancy remains another front line. In wealthy nations, the anti-D injection has prevented most deaths from Rh incompatibility since 1968. But access is still limited across much of Africa, Asia, and Latin America, and tens of thousands of newborns still die each year from a condition that modern medicine already knows how to stop. The story even reaches into recent history. During the COVID-19 pandemic, some studies suggested the Rh factor might subtly influence infection outcomes, hinting that this ancient trait may still be shaping survival in ways we're only beginning to measure. And science keeps pushing forward toward artificial blood and lab-grown red cells, hoping to build a steadier supply that no longer depends entirely on donors. In that research, rare blood types like Rh negative remain vital, helping scientists understand compatibility and reduce immune reactions. It's a profound reversal. A trait that once filled families with dread during pregnancy has become, in the modern world, a gift that saves lives every single day. Blood is not just a red liquid moving through you. It is a living archive. Every drop carries mutations, adaptations, and survival stories stretching back tens of thousands of years. Rh negative blood, far from a mistake of evolution, may be one of the quietest records we have of who we are and where we came from. We've walked past the myths together. Not Atlantis, not aliens, not a secret superpower hidden in the veins of a chosen few. What the DNA actually reveals is something stranger and more human. A single missing protein, a small change in one gene, carried forward by isolated mountain communities, by survivors of ancient bottlenecks, by mothers who endured losses they could never explain. It shaped the Basques. It left its trail along forgotten coastlines. And it still saves lives in emergency rooms tonight. If your family carries Rh negative blood, you are not holding a legend. You are holding a thread that runs back through the deep past of our species, proof that survival was never guaranteed, only earned by the narrowest margins of chance. So the next time you see your own blood type, remember, you're not just reading a letter and a sign, you're reading history. If your blood could speak, what story would it tell? Share your blood type in the comments, and let's see how many carriers of this ancient code are here right now. And before you go, subscribe and join us, because the stories hidden in our DNA are only just beginning to be revealed.